be your part 2 video for 2-6, the quadratic formula. This example actually has 3 different parts here. We are going to look at the graph of each of these equations, and then we're actually going to use the quadratic formula to go through and find the roots. Now, I'm not going to graph these exactly. I'm just going to give you an approximate idea of what the graphs look like. All 3 of these are opening up, so that's just something to keep in mind as we work through. So for the first one over here, this one does have a y-intercept of 3. It opens up, and it actually crosses the x-axis in 2 different places. So your graph is going to look something like that. And again, we just want an approximate idea for us to go through so that we can solve these. So now we're going to do the quadratic formula. Your a is 2, your b is -7, your c is 3. So we're going to have 7 plus or minus the square root, -7 squared minus 4 times 2 times 3, and that's all over 2 times 2. So 7 plus or minus, this is going to be 8 times 3 is 24. 49 minus 24 is going to be 25. So square root of 25 is 5. This is 7 plus or minus 5. All over 4. So we're going to get 2 answers here. We do 7 plus 5, that's 12. Divided by 4 is 3. 7 minus 5 is 2. Divided by 4 reduces to 1/2. So you have 2 real solutions there. 2 real solutions. The next one has a y-intercept of 9. And if you actually look at the graph of this, it's going to come down, it's going to touch the x-axis at one place and then go back up again. So if we look at this one with the quadratic formula, I have x equals -12 plus or minus the square root of 12 squared minus 4 times 4 times 9, and then that's all over 2 times 4. So we have -12 plus or minus, inside the square root, 12 squared is 144. 4 times 4 times 9 is also 144. So when we subtract them, we get 0. Well, the square root of 0 is just 0. So this is actually just -12 over 8, because it doesn't matter if you add or subtract 0 from -12, it's still going to give you -12. So -12 over 8, both of those can be divided by 4. And so that's just going to give you one solution of -3 over 2. Now for the next one, this graph actually has a y-intercept of 8. It's going to come down like this and then go back up. My video is in the way a little bit here, so I'm going to do my math up here a little bit close to the graph. So I have x equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 8, all over 2 times 1. So that's -2 plus or minus. Inside the square root, I have 4 minus 32. That's going to give me a -28, and I will have to go through and reduce that, or break that down. So greatest perfect square factor of 28 is 4, so that's going to become a 2, and then I'm also going to have an I with the negative. So that's -2 plus or minus 2i square root of 7 all over 2. So that's -1 plus or minus I square root of 7. So with this one, you actually have an I in your answer. And these 3 examples basically display everything that you can tell without fully going through and solving the question. We're going to be using something that's called the discriminant. The discriminant is going to be the number that you get inside of the square root before you actually take the square root. If that number is positive, like it is over here on the left, the 25, you're going to get 2 answers, 2 real answers. They might be rational, they might be irrational, depending on what that number actually is, but there's 2 answers that exist, 2 places where it crosses. For the middle one, if you get a 0, that means that your graph is only going to touch in one place. So in this case, I got my 0, I only had one solution. It only touches the x-axis once. The third option, if you get a negative inside the square root, that means that you're going to have i's in your answer, which means your graph doesn't actually cross the x-axis anywhere. So it could be opening up like this, it could be below the graph, opening down where it doesn't cross through, but those are the three different types of things the discriminant can tell us. And here's what I just told you. I'll scroll a little bit because again, my video is in the way some there. So the radicand is what you call the thing that is inside the square root. That's what's going to determine the nature of the root. So we call that the discriminant. So you can see there that's the b squared minus 4ac of your quadratic equation. And then you have your conditions if that's positive, if it's 0, and if it's negative. So if they ask you to describe the number and type of roots, the number is going to be 2 or 1. The type is real or complex. Complex would be if you have an I in your answer. Sometimes they'll interchange imaginary for complex. Just be aware that that can happen. So next we're going to use that information to actually solve a couple of questions. This one is an interesting one. It says Rachel is about to serve and she tosses a tennis ball straight up into the air. The height is given by this equation. H of t is equal to negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? So to figure out if this is possible, I want to see if the quadratic equation has any type of real solution. If it does have a real solution, then it's going to be possible. So I'm going to replace the h of t with that 4 and see what it gives me. Now, before I can go through and do any type of quadratic formula, I do need to move that 4 over because the quadratic formula and the discriminant only apply if your equation is equal to 0. So I am going to subtract the 4. That makes that a minus 2 instead of a plus 2. And then all I have to do is check my b squared minus 4ac. So my b is 5 minus 4 times negative 5 times negative 2. Well, that's 25. This is going to be negative 20, positive 40 with another additional negative. So that's going to be minus 40, which gives me a negative 15. Well, negative 15 is less than 0, which means this has 2 complex roots, no real solution. So because this has no real solution, there is no time where this ball would actually reach a height of 4 meters. And you could test that out. This is a negative quadratic, so we could actually find what the vertex of this is. And if you look at the y-coordinate of the vertex, that should be the maximum value. And it is actually less than 4. I can't remember if it's 2 point something or 3 point something, but there's no possible way of using this equation that the ball could reach a height of 4 meters in her serve. Okay, the last example for this, example 5, we want to know what value or values of b will cause this equation to have one real solution. Well, one real solution means that your b squared minus 4ac has to be equal to 0. And that's all I'm going to do. I'm going to take all my numbers, including the b, which I'm actually going to plug in for the b, and I'm going to solve this. So b squared minus 4 times my a times my c, I want to see where that is equal to 0. So this, whenever we multiply, it is going to be a negative, and I do have my paper here, so I'm going to look at that and see what it is. So you get 144. We can solve this using the square root property, so I can take the square root of both sides. And we get b is plus or minus 12. So there are actually 2 different b values that will cause this to have one real solution, positive and negative 12. If it asked you to have two real solutions, you would be looking at where your graph is greater than 0, or where, the b squared minus 4ac, the discriminant is greater than 0. If it said where would it have imaginary solutions, you would be looking at the less than 0. So that wraps up our 2-6 quadratic formula. If you want to look in your textbooks, there is a concept summary on page 114 that just kind of goes through all the stuff with the discriminants, introducing the quadratic formula, how to plug into the quadratic formula, and that kind of stuff. So go back, rewatch the first video, rewatch this video, and as always, reach out to me if you have any questions.